Welcome to this video. So in this video we are going to prove the identity x k folding multiplied by n combine x is equals to n k folding multiplied by n minus k combine x minus k. Okay, so for us to prove this identity we need to know three definitions. Okay, so the first one is the factorial. So if you are given n factorial, what does that mean? Okay, so n factorial is the same as n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3. Okay, so this pattern continues until you reach the term n minus k plus 1, and then you write the last term, which will just be n minus k factorial. Okay, so this is the definition of what a factorial is. So we have to know the definition of a factorial. The second one, okay, we have to know the definition of what we call as a folding factorial. Okay, so if I have n raised to the power k in brackets like that, okay, we call that as a folding factorial. So we read this as n k folding. So n k folding is the same as n minus n multiplied by minus n multiplied by n minus 1, okay, and then multiplied by n minus 2 multiplied by n minus 3, okay, all the way up to the term where I have n minus k plus 1. Okay, so we see that the folding factorial is actually inside the factorial. Okay, because if I get these terms from there all the way up to there, you see that that's exactly what we are saying is the definition for a what? For a folding factorial. Okay, so you have to know that the folding factorial is defined as this. And then the third one, okay, we have to know the definition of a combination. So if I have n combine k, now let me use x, okay, if I have n combine x there, this here is the same as n factorial divided by n minus x factorial and then x factorial, like that. Okay, so these three definitions here are going to help us prove this identity here. Okay, so now that we've known the definitions, let us try to prove, okay, that left hand side is actually equals to the right hand side. Okay, so we'll start from the left and then we see if we can get what we have on the right. So I'm going to say, okay, I'm going to say left hand side is equals to, I have x k folding, okay, and then multiplied by n combine x. Okay, so this one here we know that it will be n x k folding, okay, and then we can expand this combination here. We're going to say the combination is the same as n factorial, and then we have n minus x factorial, okay, and then we have x factorial. Okay, and then from here we can expand this factorial that has n, okay, this one here, and we can also expand this x factorial. So what we have is x k folding, okay, multiplied by this n factorial. We're going to write it as n minus 1, n minus 2, okay, all the way up to n minus k plus 1, and then I have the last term, which is n minus k factorial. Okay, from there I'm going to say let me divide all this by, okay, let's expand the x factorial. So it will be x multiplied by x minus 1 multiplied by x minus 2, and then all the way to x minus k plus 1, okay, and then x minus k factorial, and then I also write this term here. Okay, so it will be n minus x and then factorial. Okay, so what do we see there? Okay, we see that starting from here all the way up to there, it's just the definition of a folding factorial. So that would be n k folding, okay, and then starting from here all the way up to okay, starting from here all the way up to here, we see that that will also be a folding factorial in terms of x. Okay, so what we have here will be, okay, this will be equals to x k falling. Okay, from here we see it all the way up to there. It's just the n k falling. Okay, and then I have n minus k factorial divided by, okay, so from here all the way up to there we have our x k falling. Okay, and then we are left with this one, which is x minus k factorial, and then we have n minus x factorial. Okay, so what we see here is that this guy and this one, they are going to cancel out. Okay, so what we remain with will be this. So we erase the top part here. Okay, so what we are going to remain with will just be n k falling. Okay, and then I have n minus k factorial divided by x minus k factorial, and then I have n minus x factorial. Okay, so now remember how we defined a combination. Okay, we said if we had n combine x, it will be this same guy, n factorial, divided by n minus x factorial, and then x factorial. Okay, so it turns out that this situation that we are seeing here is exactly what we have there. Okay, so we can prove it, or we can show it. So we are going to say, okay, we're going to say on top there, okay, I have n k falling multiplied by n minus k factorial, and then down I have x minus k factorial. Okay, so it turns out that this part here is just a difference, okay, between n minus k and x minus k. So if I have n minus k minus, okay, x minus k and then factorial, what am I going to have inside here? Okay, it will be n minus k, then this minus multiplied by x, I get minus x. This minus multiplied by minus k, I get plus k factorial. We see that inside here, the minus k and the k is going to cancel. So what we're going to remain with there is just n minus x factorial. Okay, so it means this guy here, we can actually write it in this form. So we're going to say n minus k minus x minus k, okay, and then factorial. So what we see here is the exact definition of what a combination is. So it means what we have there will just be n k falling, okay, and then this one here will just be a combination of n minus k and x minus k. So this will be n minus k, and then I have x minus k. Okay, so all this part here, it has just become this part. Okay, so once we do that, okay, we notice that what we have now is the same as what we had on the right hand side. Okay, so we started with the left hand side here, and then we end up with the right hand side there. Okay, so we can say hence proved. Okay, hence proved. So we are done with this proof. So thank you so much for watching. In the next video we do the proof for B.